Hello there, Mr. Sutton here, bringing you the IM3 Chapter 3 Post-Quiz Extra Practice Number 3 solutions on reviewing of factoring. There's a puzzle that goes with this one. Let's go ahead and take a look at that. So here's the puzzle that goes with our practice review. We're trying to solve the riddle, what do you use to unlock the doors of a monastery? And the idea here is we have some expressions over here on the left side that we have to factor. We'll have to break them into two different factors represented in the following two columns, and then we just have to make sure we match the right factors together, and that tells us where to put one of these letters. So for example, let's say that I do number one and I figure out, I doubt this is the answer, but I figure out that, hey, maybe it's 1 and n. That means in spot number 1 down below here, I would put an n if those were the two things that actually went together. So let's get to the bottom of this and figure out what's going on with this monastery. So here we go with problem number 1, and we're going to see that all the problems on this puzzle can actually be solved with grouping since they all have 4 terms. So for problem 1, first 2 terms, it looks like I can take out a common factor of x squared. That leaves me with an x minus 2 for the leftovers there. And then for the next one, we have a 3 that I can take out from 3 and 6, leaving me with an x minus 2. Since I have x minus 2 repeated, I can take that out as a common factor, and that leaves me with x squared plus 3 as my leftovers next door. So let me go ahead and find these now in my answer columns. So x minus 2, x minus 2. I don't see that until I get to this e right here. So we have an e, and then that means I have my x squared plus 3 over here. That's 5. So 5e then. Let me put that letter in there. On this one, we're going to take out something from the first 2 terms, like an x squared. That leaves me with x plus 3. And then for the next 2 terms, I can take out a 4 out of 4 and 12. So that's going to be an x plus 12 divided by 4 is 3 again. X plus 3 can come out as a common factor. That leaves x squared plus 4 as the other factor. And it looks like I've got my x squared plus 4 right there, number 7. Now the x plus 3 is an s over here, so 7s, let me put that in there. Using grouping on this next one, we can take an x squared out of the first 2 terms. That leaves me with x plus 5. For the next 2 terms, since my third term's negative, I'm taking out a negative here. So negative 7 can come out of all that, leaving me with x plus 5. X plus 5 comes out as a common factor, and that means we have x squared minus 7 as the leftovers factor. X squared minus 7 is here under number 3, and the x plus 5 is up here as an n, so that means that 3 is going to be n. On this problem, this is the first time I have to do more than take out an x squared from the first 2 terms. This time, since we have the 6 and the 4, we can take out a 2 along with the x squared. 6x cubed divided by 2x squared, that's going to be 3x. And then 2x squared divided by, or 4x squared divided by 2x squared, that's going to be a plus 2. For the next 2 terms, 3x and 2, all I can do is take out a 1 since nothing else goes into those. That leaves me again with 3x plus 2. But now I can take out my 3x plus 2 as a common factor, leaving me with 2x squared plus 1 as the other factor. And then 2x squared plus 1, that's right here, that's number 2. And then 3x plus 2, that is right down here as O. So that means that 2 and O go together. So number 2 here, I'm going to put an O there. On this next problem, it looks like I can take a 5 and an x squared out of my first 2 terms. That leaves me with x, and then 5x squared divided by itself is a minus 1 there. For the next 2 terms, I can take out a 3, leaving me with an x minus 1. So x minus 1 comes out. 5x squared plus 3 goes in. And then 5x squared plus 3, that's a 6 over here. And the x minus 1 that goes with that belongs to, this is a y down here. So we have 6y right there. Using some grouping on this next one, I can take a 7 and an x squared out of those first 2 terms. 14x cubed divided by 7x squared, it'll be 2x. And then 21 divided by 7 is 3, so negative 3 and then the x squareds cancel there. For the next two terms, my third term's negative, so I'm going to take out a negative, and I can't really take out anything else, so I'm taking out a -1 then, leaving me with 2x and -3. So 2x minus 3 comes out as a common factor, and then 7x squared minus 1 is going back in as the duplicate, or the leftovers factor. 7x squared minus 1, that's right here, that's 4. And then 2x minus 3 is down here as k. So 4k. There we go. And now we are one away from solving the puzzle. All right, final problem. For my first two terms, I can take out a 2 and an x squared. That leaves me with a 2x and a 3 plus 3. For the last two terms, I can take a 3 out of those. So that'll leave me with a 2x and a plus 3. 2x plus 3 is coming out. 2x squared plus 3 is going back in. So those are pretty similar looking. 2x squared plus 3, that was number 1, which, not surprising, that's the only one left. And then the 2x plus 3, that's right here, that's m. So 1 is actually m. And now it's time to solve the puzzle. So just to review the riddle here, we said, what do we use to unlock the doors of a monastery? Monkeys. Right? Get it? Because like a monk goes to a monastery and the keys, and anyway, Mr. Sutton signing off.